Okay, good day, grade 9s. I trust that you are well. This video is just to revise on transformational geometry, transformation geometry, which is actually quite interesting as well. It's not a very difficult section and it's actually quite enjoyable. So, transformation geometry is not something that you see too often in grade 10, 11, and 12, but there are questions that's plugged in, like for example, in functions or somewhere along the line that you'll see. So, whatever you learn in grade 9 is extremely important for grade 10, 11, and 12. So you just need to properly know the content. So transformation, right? It's like the movie Transformers, where those cars just change. Optimus Prime, he changes to a truck and whatnot. Transformation means to change. So if we look at a coordinate on the Cartesian plane, we need to change that location. And there's three ways we can transform an object, right? Or transform a figure rather than as opposed to an object. Transform a figure. The first way is through translation, right? Translation basically means shifting something from either left or right or up or down. So you get two types of translations. You get a horizontal translation that's moving from left to right. Of course, it's going to affect your x value. And you also get a vertical translation that is shifting something from up or down. And from there, you get a reflection. Now, a reflection is like looking at yourself in the mirror, right? So if you have a mirror, you can reflect an object about the x-axis, the y-axis, or you can reflect it upon a line, about a line. Like, for example, the line y is equal to x, and I'll get to that uh, during this lesson. And lastly, you get rotation. Excuse me. You get a rotation. Now, let's look at a translation. Right? A translation is shifting about a coordinate either vertically or horizontally. Let's take the coordinate a, let's say it's a 2 and 3, something simple for now. Right, I'm going to take the simple coordinate 2 and 3. Remember, coordinate is always in the form of x, y. Coordinate is just a location, right? And we can plot this onto the Cartesian plane. So I'm going to try to be as accurately as I can, as accurate as I can. So you should also get into the habit of using your pencil and ruler, and you always need to use a pencil and ruler whenever it comes to drawing graphs. I'm just going to draw a very simple Cartesian plane. And notice what I'm doing here. I'm using my ruler and I'm measuring everything 1 centimeter apart. I notice that some learners measure, like let's say from 0 to 1 is 1 centimeter, and then from 1 to 2 it's like 5 centimeters, and that's incorrect, and your coordinates is going to be incorrect as well. So this is my y-axis, the vertical axis. We looked at this when we looked at graphs. And of course we have our x-axis, which is our horizontal axis. And again, I'm going to use my ruler to measure this as neatly as I can. Right. So of course it can continue to infinity from left to right. Right, so this is how your Cartesian plane. Yeah, my line is a bit skewed there because I turned the page a bit, but your graph should look much neater than mine, hopefully. And let's say this is 0, 1, 2, 3, 4, -1, -2, -3, -4, -5, right? Okay, so from there, what we can actually do, we can say this is 1, 2, 3, 4, -1, -2, -3, -4, right? And now let's plot the point A, 2, and 3. So it's so the x value is 2, the y value is 3. So we locate 2 on the x-axis and we go up 3 spaces, right, as accurately as we can. So this coordinate, a coordinate is just a point, it's like a dot. So it's A, 2, and 3. Now, let's translate this. So they'll probably give you a rule. They'll say, translate, let's say, let's to left and 2 I'm using 2 and 3 quite a lot. Let's say 4 units up. Let's say 1 unit up, because the Cartesian plane is quite small, so there's not enough numbers here. But it's possible that they could have said that. Now, if I look at this, let's create a general rule. Remember, coordinate is always in the form of x, y. And I need to take this A and I need it to travel to a new location. Specifically, it needs to shift 3 units to the left and 1 unit up. So remember, a left or right shift affects your x value. It's going to affect 2. An up or down shift will affect your y value. It will affect 3. So a coordinate is always in the form of x, y. Right? What am I doing to the x value? We said I'm shifting 3 units to the left. When you shift to the left, you need to subtract 3. If, for example, it was 3 units to the right, then I'm going to say x plus 3. But in this case, it's going to be x minus 3, and the y value is going to be y plus 1, because I'm shifting it 1 unit up. If it was 1 unit down, I'm going to say y minus 1. So what is my new value, or what is my new coordinate? It's going to be, remember A was 2, 3. My new coordinate, I'm going to substitute 2 in the place of x. It's going to be 2 minus 3, which is negative 1. So A prime, we call it A prime, it's the new coordinate of A, is 2 minus 3, which is negative 1. And I'm going to substitute y in the place, 3 in the place of y, so it's going to be 3 plus 1, which is 4. So my new coordinate is actually going to be negative 1, 4. So it's negative 1 and 4. That's my new coordinate. And that is how I shift, or rather, that is how I translate a coordinate. Now, moving on from there, you also get reflection. Now, reflection is like looking at yourself in the mirror. You see a reflection of yourself. Let's draw the Cartesian plane. So the Cartesian plane. And let's draw the x-axis as well. Let's draw this x-axis here as well. And let me just mark points. This is 1, 2, 3, 4, 5, 1, negative 1, negative 2, negative 4. Right, okay, so I think that this looks actually much neater than the previous one. And don't forget to label your graph. I'm not too sure if I labeled my previous one, but this is the y-axis, this is the x-axis. I have to label it. I believe I did, right? It's always y and x. You need to label your axis. So this is 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So to the right of 0 is your positive integers, to the or your positive values, by the way, because remember there's also decimals in there, so it's not limited to only integers. And above 0, the y-axis, those are your positive values as well. To the left of 0 on the horizontal axis is your negative values, and below 0 on the y-axis is your negative values as well. Okay, so let's take a random point. Let's take point B. Let's say the point B is negative 1 and 2, for example. Negative 1, 2. B, negative 1, 2. Right? Okay, this should actually be more accurate. I'm just rushing a bit here. But you can see that's negative 1, 2. It's the coordinate here. And, right, excuse me. I say reflect B about the x-axis. What does that mean? It means that if I have a mirror here, right, I place the mirror here, and it's going to reflect. So whatever I see here, it's going to, the reflection will be here. So B will be somewhere here, if you think about it. If you take a physical mirror and you look at that mirror, you'll see that B should reflect somewhere here. So the golden rule is that when you reflect about the x value, or x-axis, the x value remains the same, but the sign of the y value changes. So B prime, the x value will still be the same. It's still going to be negative 1, but the sign of the sign of the y value will change. So it's going to be -1, -2, as such. -1, -2. And when we reflect about the y-axis, so for example, we place our mirror here, right? So whatever you see on this side, you see on this side. Let's reflect, let's take a new coordinate, just so that we don't cluster and confuse everything. Let's say -4 and 5 this time. So it looks much more neater, right? So let's say this is C, -4 and 5. Now the x value is -4, the y value is 5. So remember the goal, when you translate about the y-axis, the y value will still remain the same, but the sign of the x value will change. So it's going to be, instead of being -4, it's going to be +4 and still 5. So this is going to be prime, which is +4 and +5. That is how you reflect about the x and the y value. Thank you.